Okay, so here we are. We are trying to solve this problem. This is number 14 in section 1.3. We have four terms. X cubed, whoops, getting off there. X cubed plus 4x squared minus 36x minus 144 equals 0. We're supposed to solve that. So how you solve this when you have four terms? Do you remember? You do two terms, two terms. You got to split them into two groups. And you take out what's in common in the first two, which would be x squared. And what does that leave behind in those first two? X squared times what? We'll go back to x cubed. That'd be x. And x squared times 4 would go back to 4x squared. Okay, now the back two, what goes into both them? If you use your calculator, it turns out 36 goes into 144. So they both have 36 in common. So you take out the minus 36 and you ask yourself the same question we said before. 36 times what? 36 times what will go back to minus 36x. So minus 36 times x, and then minus 36 times what will go back to minus 144. If you divide in your calculator, you'll find it's plus 4, right? Negative times positive, negative 36 times positive 4 goes back to negative 144. Let's keep the equal 0 there. Then notice those two now both have a matching x plus 4. You're always going to get a match like that when you do four terms, first two, last two. You're always going to get a match. This is called grouping, factoring by grouping. Okay, now, how do we finish this thing up? Because we're not done there. Well, the trick is, let me ask you this. What if we had x squared times w minus 36 times w equals 0? What would you do? You would look at these two terms, you'd factor them, right? What would you take out? What do they both have? A w. I don't know why I'm getting that funny little mark there. Let me try this again. You would look at them and you'd say, well, they both have a w, right? Take out the w, that leaves x squared minus 36, right? They both have a w. You just take a single w, right? So instead of w in common, what if they had parentheses x plus 4 and parenthesis x plus 4? What if they both had that in common? You would take out a parenthesis. Whoops, I don't know why I'm getting such funny little marks there. You take out a parenthesis x plus 4 that they would both have in common. So it's the same thing here. They both have a parenthesis x plus 4. Take out a parenthesis x plus 4, and what does that leave behind? X squared minus 36, because that x plus 4 could go boom and be back in those two places. You see how that is? It's just like taking out a w in common. And now we can do one more step from here. Well, one more step on factoring. X squared minus 36, that factors as x plus 6, x minus 6. All right, and then what do we do from there? Each of those equals 0 separately. So now we have x plus 4, put it up to here. X plus 4 is 0, x plus 6 is 0, and x minus 6 is 0. And you know what that's going to do, right? As you jump them to the opposite side, you're going to get opposite signs on all of them. So negative 4, positive 6, negative 6 are our three answers. They want three answers separated by commas. That's the final answer on that one. Okay. So let's move on to another problem. Okay, so here we have number 15. We have the square root of y. Whoops, I'm getting some funny marks there. Let me try it again. Whoops, getting that again. Okay, so the square root of y plus 7 equals 8. So what do we do to solve this thing? What do we do to get rid of that root? We second power both sides, don't we? So parenthesis, 2 power both sides. 2 power cancels a root, and so that leaves us with just y plus 7 on the left side because the 2 power canceled out the root. The other side, it's 8 times 8. So that's 64. So everybody see why on the left side I did not square the 7 to be 49. I did not square the y. Why not? Because the root and the 2 power canceled each other. The 2 power is gone. But on the right side, nothing canceled it out. There was no root to cancel the 2 power, so it just made it 64. Then it's easy. Just subtract 7 from both sides. Y equals, what's that? 57. And we're done. So that's all that's required on that problem. Let's go to the next one. Okay, so this next one's going to be the hardest. We have fractions. If you can read all that. Here, let me write it a little larger so we can all see it. So it's 2. Whoops, getting those funny marks again. So it's 2 over x plus 3 plus 4 over x minus 1, whoops, equals negative, I'm not trouble with that, negative 5/3. Okay, so we need to multiply through this thing by a common denominator. So what's the common denominator for this? Well, it's everything. So we need the 3, we need the x plus 3, and we need the x minus 1. And we need to put that all the way across. So it's going to be 3 x plus 3 x minus 1 all the way across like that. Okay, we get to there. So you put the whole common denominator, which is every part of the denominator, top, 3, x plus 3, x minus 1, all the way across the top. And then what do? You cross cancel whatever matches. The x plus 3's cancel in the first fraction. You multiply what's left over. What's left over? 3 times 2, 6, and the x minus 1. Plus, what cancels in the middle fraction? The x minus 1's, what's left over? 3 times 4, 12, and the x plus 3. Okay, on the right fraction, the 3's cancel. What's left over? Negative 5. And then you FOIL what's there. X times x is x squared minus x plus 3x minus 3. Gather like terms over there. X squared minus x plus 3x is plus 2x. And then go ahead and distribute that minus 5 through what's left. So minus 5x squared minus 10x plus 15. On the left side, 6x minus 6 plus 12x plus 36. Okay, so I can just bring that, gather like terms. 6x and 12x is 18x, and minus 6 plus 36, what's that? Plus 30. So there we go. So what have I done so far? I have just simply multiplied all the fractions, the tops, by the whole common denominator, every part of the denominator. 3x plus 3, x minus 1, top. Cross-canceled, like right here, I cross-canceled the x plus 3's and I multiplied whatever was left over. 3 times 2, 6, and then the x minus 1. So you cancel what you can and bring down, multiply down whatever's left over. So now we get to here. What should we do with this? Well, whenever you see x squared, you've got to have a game plan. So let me recopy this to another page. We have some more work to do. So 18x plus 30 on the left side. And the right side is minus 5x squared minus 10x plus 15. Minus 5x squared minus 10x plus 15. Do I have that right? I do. Okay, so now you need to have a game plan. Whenever you see x squared with an equal sign, here's x squared right there. Whenever you see x squared with an equal sign, you have to have a game plan. What's the game plan? Number one, you got to get a 0 on one side. You have to get a 0 on one side. And then step two, you try to factor, if you can, with the parentheses. So how am I going to get x squared? Well, not only that, you want to get x squared. I'm gonna move x squared so it is positive. So I want to grab this minus 5x squared and I want to jump it over here. And I want to grab this term, and I want to jump it over here, and I want to grab the 15 and jump it. I want to jump all three of them to the left side. Why am I doing that? Because that'll make the x squared term positive. That's just a lot easier. So when things jump to the other side of the equal sign, they change signs, don't they? So it'll become a positive 5x squared plus 10x minus, whoops, getting some mess there, plus 10x minus 15. So those three jumped over and changed signs. And then there's also the positive 18x and the positive 30 that were already there. Now there's just a 0 on the right side. Let me clean that up a little bit. It's getting a little messy here. So plus 30 equals 0. Right? So the 5x squared, the minus 10x, and the plus 15 jump to the other side, change signs. Now you combine like terms. What do we have here? 5x squared plus 10x plus 18x is 28x. Minus 15 plus 30 is plus 15 equals 0. So we did step one. Check. We got a 0 on one side and we moved x squared so it is positive. We don't like x squared being negative. It's just hard to deal with. So we move it to the side where it'll be positive. It had to jump to the other side. So everything jumped to the other side. And we got a 0 on the right side. Okay, now we got a factor. How do we factor? We're thinking about FOIL, right? Oops, getting that thing there again. All right, so FOIL. So 2 parentheses. So front times front to make front. What times what makes 5x squared? 5x and x. And last times last to make last. What times what makes 15? Well, 5 times 3 makes 15. That's not the right order, though. Here's how we'll see it. So right now, front times front's making front, and last times last is making last. But the trick is the middle. How do you get the middle? OI. What does that O and that I stand for? Inner with inner, outer with outer. Inner with inner is 5x, outer with outer is 15x. Can they combine to be the middle, the 28x? Can 5x and 15x make 28? No, they make 20. If you add them, if you subtract them, it's 10. It's not working. What's the problem? I need to switch the 5 and the 3 and put them in the other order. You see, the order on the back two matters. Not only that, I should have known I can't have 2 5s in the same parenthesis. You can never have 2 numbers in the same parenthesis that have anything in common, let alone the very same number. So let's swap them up. The 3 goes here. The 5 goes there. Let me erase what we had here. And say, okay, let's try it again. So we still have front times front's making 5x squared, and last times last is making 15. But now the 2 inner is 3x, and the 2 outer is 25x. You see, they make 28. When they're both positive, they add to be 28. So that's the right combo. They've got to both be positive like that. All right, so now we're rolling. Now we can set each one equal to 0 separately. So we have 5x plus 3 all by itself equals 0, and the other one x plus 5 all by itself equals 0. Just jump it over. This is negative 5. That's one answer. Jump this one over. That's negative 3. Divide by the 5. That's the other answer. So negative 3/5 and negative 5 are the two answers to that problem. That was a long one and a hard one. Okay. Okay, so let's go now to Chapter 2. Here we have a problem from Chapter 2, Section 1, 2.1. They're giving me a picture of a function, or it's a relation, and they're wondering, is that relation a function? Well, let me give you the function definition first off here. Function, whoops, getting some marks there. Function definition. When every input x goes to only one output y. That's the definition of what it means to be a function. They're going to keep using this over and over again. So here, these are the inputs. This is called the domain up here. Domain. Whoops. And this side is called the range. This is also called the inputs. And this is the outputs. Whoops. A little trouble there. Okay, so the inputs or the domain is these guys, and the outputs or the range is these guys. All right, so here's the function definition. When every input goes to only one output. Well, what's happening here? Is this relation, Beth is going this way, see the arrow, and then Emma's going that way. Now, is that a problem? Actually, no. That's okay, because Beth is an input, she only goes to Bob. Emma's an input, she only goes to Bob. Doesn't matter they go to the same output. Beth is an input going to only one output. Emma is an input also going to only one output. And the bottom two are fine. The Devin only goes to David, Sarah only goes to Mary. This one is a yes. It is a function. Yes, it's a function. Let me say that a little cleaner. Yes, it's a function. Okay, and then down below they're going to say, list the domain. The domain is Beth, Emma, Devin, Sarah. This option right here. Whoops, I'm not making that very clear. It's going to be this option right here, because that's the inputs. So that makes sense. Let's see the next one, and we'll see when something is not a function. Okay, so this will be number 2. And we can see this one's not going to be a function. Why? Because C, C goes to B and D. That's a problem. That's one input. Notice C over here goes to B and to D. That's one input going to two outputs. So that's no. That's not a function. Remember the rule for a function. Every input can only go to one output. So this is not a function. Does this relate? It's a relation, but does it represent a function? No, it does not. Unlike number 1. Number 1 was okay, but this number 2 is not okay, because C, that input, is going to two outputs. That's not allowed. Okay, let's move on to number 3. We're going to see another one that is asking us whether something is a function or not. Notice it's just listing some points there. So those are x and y values. So I think the easiest way to do this would just be to say, what are all the x values? What are all the y values? So there's 4 is an x value going to -9, a y value. -7 is an x going to 7. I'm grabbing them over here. And then, I can't read them now. And then 6 is an x value going to -7, a y value. And then finally, this is x, y, x, y, x, y. And then final x value is 4 going to 5. Now, instead of writing 4 again, I've already got 4. So I'll just say 4 also goes to 5. And that's a problem, isn't it? So there's one input going to 2 different outputs. So we would say not a function. You can't have one input going to 2 different outputs. That's not a function. Okay, so I'm going to stop section 2.1 here. And I'm going to save this in the Tuesday, Thursday course file, but in reality, if you want to see the rest of section 2.1, so let me write this for you, the rest of the 2.1, go to the Monday, Thursday playlist on YouTube to get the rest of 2.1, because I didn't record it all here. You'll find the rest there. And so that's it.